So this is going to be a very brief overview, as I said, of the Durango. That was the largest font I could have and made it all fit. But the basic gist of the thing is this, all right? This is an 8-core PC clocked at 1.6 gigahertz. It's, there's some subtle variation between what the Orbis and the Durango offer as far as the number of CPUs that are available that aren't system reserved, the speed of the memory. And as you can see that the Durango is DDR3 memory, and the Orbis is DDR5 memory. Is that correct? GDDR5 memory. So there's about a 20 or 30% performance boost just in memory bandwidth there. We don't know what that'll actually translate into the game performance. We'll see over time how that works out. The real main difference, I think, between the two platforms from the 50,000-foot view is going to be what the system reservations do to the CPU and the memory budgets and whatnot, what's available from those perspectives. You'll see that with the Durango, it does have 8 gigabytes of memory, but only 5 gigabytes if it's available to a game title at any one time. They have a system reservation of 3 gigabytes for the system OS, and also for another partition, which I will show you in a moment, the way that the Durango is organized and the way the operating system is presented to the game application. Also note that the 68 gigabyte a second GPU bandwidth, memory bandwidth is going to be obviously, 172 on the Orbis, so significantly higher. Also note that the Connect is available on the Durango at all times, if you guys weren't already aware of that. Part of the system reservation from the 8 CPUs, they reserved 2 of them for the OS. One of the CPUs is dedicated 100% to the Connect, so it's always running at 30 hertz, 60 hertz. Let's call it 30.
It's Connect, I don't care about Connect.
All right. Also, the Durango, which Steven's going to give a short presentation on in a moment, has a part of the chip die dedicated solely to an audio processor. So some of the CPU load that we might otherwise be running on the Orbis, which I'm sure Steve will get into more detail on.
More detail than anyone wants to know about.
I don't know if you can beat this slide.
Okay, and then from here on, you'll notice the slides improved dramatically. That's because I copied them all out of XFest slides. All right, so this is the basic way that the Durango is organized from our perspective. There's basically what they call three operating systems running on this thing simultaneously. There's the host OS, the shared partition, and the exclusive partition. If you saw the demo that they were giving with the Durango, you saw like how they were able to like very rapidly switch between applets like Netflix and whatnot, and back to the game and TV and whatnot. Those were basically, they were demonstrating the shared partition and the exclusive partition. We live in the exclusive partition basically entirely. That's going to be our 5 gigabytes. It's going to be our 6 CPUs. There's no CPU reservation set aside out of our clock. On the exclusive partition, we have 100%. So there's, if you're familiar with PIC, those 1 millisecond slices that we always see on the Xbox won't be present. And the cost of this thing is that 3 gigabytes and 2 CPUs are basically dedicated to this test. The host OS, you can pretty much ignore that. Just be aware that it's there. It's essentially where the security layer on the Durango lives. They've isolated it in a way that is going to make it very difficult for the hackers to surmount it, although we know eventually they probably will. For the sake of this slide also, be aware that the shared partition is running like a WinRT OS, something that looks like Windows 8. And the exclusive partition is supposed to be a very thin layer directly down to the hardware. And obviously that's going to vary depending on the API. All right, and then there's 4 states that your game can be in when it's running. It's either full running, which is you have all 5 gigabytes of memory, you have 90% of the GPU, you have 6 processors, you have minimum guaranteed networking bandwidth, you have full access to the video hardware, decompression hardware, the audio hardware, etc. So this is when your game is running full screen, exclusive. This is what the user's doing with the thing. Now there's these 3 other states that the game can basically be in. When they switch back and forth between this shared and exclusive partition, and they're running a game, you could potentially be in something that they call constrained mode, which means that something in this exclusive partition is running at the same time that something in the shared partition is running. Now, they won't eat any of your CPU up. Well, actually, yes, you have 4 CPUs that you guarantee, 4 cores, and you have 45% of the GPU. But be aware that when you're in this constrained mode, you're not actually going to be playing the game, right? So you may have some rendering tasks and whatever, but the game doesn't have to be something that is interactive at that point in time. And then there's a suspended mode, which you can see you have no CPU reservation, but you don't lose your memory. So this would be like, let's say the player switches to full screen television, or they're watching Netflix or something like that, right? So you basically, you're not running, you're in a suspended state, but all of your memory is intact. So all they have to do is fire you back up again, start giving you clocks. And then of course the not running mode, which is completely unloaded, you don't have any memory, you don't have any CPU. The next time you launch, you have to reload and reinitialize everything. And then here's like a schematic diagram of what these state transitions look like, right? So you're gonna get messages, we're gonna have to service messages from the operating system telling us when to transition into these various states. Anytime that you go into this state, the suspended state, the game is gonna automatically generate a save game, right? So that way, whenever you're coming back into the resume state, or if it goes rather into the not running state, or from the suspended state, it'll generate the save game automatically. It won't be something that the user will have to interact with. So a lot of the mechanic that we have in the game right now, as far as save and quit, and asking the user if they want to save and stuff like that, will sort of be more transparent because of the model that they're applying. Which brings me to the next thing. Save games and the way that they're organized. It's basically transparent to the end user as far as the way that the game is saved. But there's a lot of this cloud storage stuff sort of built into Durango, and we have a very large title-specific storage per game and per title and user. So you can see that online, where I can't recall what the online limits were for console title storage. They weren't very large in the 360. But
Cloud saves or for the actual, for the title storage?
like both essentially.
Yeah, it was like, the title storage was measured in K.
Yeah.
I think it was 64.
Well, you can see that we have 150 megs of title-specific storage now. So they're actually intending to use this a great deal. And then 250 megs per title per user. So basically they're planning on save games and anything else that you can generate in the game, ultimately ending up on this server. We can also deploy things into this, so we can put things like into large things in title-specific storage, like bonus weapons or free content or whatever we want to deploy down to the user and have it available to the end users. Okay, on to the next thing. This is basically the way that Durango is going to handle its installs. You break the title up into chunks. You have a 3 gigabyte limit to these chunks, and you specify what these chunk IDs are via this title image file. When it's pulling down and installing these chunks, it's going to do them in the order that you specify in this file. However, the runtime can dynamically modify the order of these things. So you can imagine like a sandbox environment, something where we plan on the user going through the world in a particular way, but maybe they bypass something or change the order that they want to go through the world. We could dynamically reorder the chunks so that way they come down in the correct order to keep the game playable for that user, without breaking the experience or causing them to wait a long time for some download to complete before they can play the game. Obviously, the idea behind this is to allow simultaneous download of the game while you're playing the game. There's a 49 gigabyte limit to Durango files, which obviously conveniently fits within the 50 gig limit on the Blu-ray drive, but each chunk is limited to 3 gigs. Now, their request, their specification for this thing was basically, don't be afraid to duplicate data across chunks if it means that the user has a better experience when downloading. One of the things that they also made clear during the same presentation there was that really through this next generation, given what the internet speeds are and deployed bandwidth throughout the world, really what we're looking at is another generation of people installing from media. So, you know, people are still going to be buying plasticware for the next 5 years. I wouldn't expect to see broad downloading.
The thing to note about that is the game never plays off of the media. Like even when you buy a disc from the store, the game is going to install onto your console.
Right.
It's just as fast.
If it wasn't clear, these things obviously come with a hard drive. Installation is not optional.
Is that shared across both Durango and Orbis or just Durango?
They both have hard drives.
Oh,
Are they both are they both install required?
Yeah, install required.
What's the deal with Orbis install required?
I believe so.
And then final things to look at here are basically the way that the chips are organized on the CPU. There's 8 hardware processor units, but you can see that they're split into 2 banks of 4. And one of the things to realize about this generation of hardware is out of order execution, better branch prediction, all the things that come with the PC world. So things like load hit stores and things that were real problems for us with power PCs are going to basically go away. You can do them, but you probably have to work really hard to make it happen. So as a general case, it's not something from a performance perspective that we're going to have to really concern ourselves with a great deal. However, this breaking hardware threads into 2 banks of 4 does represent an enormous potential performance problem, because you can see that memory accesses, let's say if you have 2 threads that are working on shared data, memory accesses have to actually pass across the North Bridge in order to share that memory and load the caches. And that is an enormous penalty. So just keep this in the back of your mind. Both the Orbis and the Durango are organized in an identical way. So when you're putting together code that does a lot of threading and shared data, make sure that the hardware threads that you're operating around are in a single module where possible. On the Durango, this is sort of easier in some ways because the system reservation is going to remove 2 of the hardware threads from one of these modules. So you never actually have to think about them. It'll be the other 2 that could potentially cause us problems. But just something to file with. And then, just for the heck of it, I threw what the CPU looks like, but I don't think we'll discuss that at this point in time. So, Steve, you wanna talk about the audio hardware?
Yeah. So, okay. So I'm actually going to talk about all of the platforms for T7, because it's really a little more interesting to compare them. So the first thing in any audio platform you need to consider is just the storage of the data, because it is going to be the primary cost computationally, because you're decoding 100 and some, up to 100 and some assets at a time. So the 360, put it in context, 360 had an off-board dedicated processor, decoded this format called XMA, which is Microsoft specific. PS3, essentially had dedicated hardware because we just pushed the SPU and there's plenty of that. And the PC is on the CPU, so there was no acceleration. Just as a sort of context, all the formats we use now, except for the Wii U, well, and the PC is not quite in this category, are VBR. So like I have a bunch of compression numbers, and they're really vague because you can compress an asset and get 50-to-1 compression, and you can compress a different asset in the same setting and get 5-to-1. It just varies a lot. It's hard to be very specific, but oh, it's just the keyboard
Left
doesn't
mouse
work.
button, yeah.
That's what this game. So for Orbis has an external hardware much like the 360. It's actually feature-wise very similar to what the 360 had, but it supports badge, best named format or worst named format ever, MP3, which is what we're currently using on the Orbis because that's what we use on the PS3, and it was really easy to get off the ground. I had to make like 2 lines of code change to the tools because the format's exactly the same. 8-Track 9, which is a Sony specific format. If you ever owned a mini disc player, 8-Track was used on that. This is a new version that supposedly also is way better, better compression, better quality. If what they claim is great, we probably will be shipping with it. I have not evaluated it yet. And then it supports MP4 supposedly, though it's not in the API yet, but they said that the hardware should support it. So that's another option. MP4 and 8-Track 9 should give us much better size to quality, essentially. But yeah, that's bottom line. We're looking at 5-to-1 to 10-to-1 compression. All of it's going to be on the hardware. I put hardware in quotes because they can patch it, which was not true of the 360 hardware, and the 360 hardware was really buggy when they shipped it, which was another set of fun. So, and there's conceivably they could add more features to this hardware as well, which I'm hoping to do, but we'll see. Okay, so for Durango, Durango has this external audio processor that's already been mentioned, and we're going to talk a lot more about it in a second. But at the core of it, it supports XMA much like the 360 does. The API is actually completely different. It has a bunch of extra constraints over it, but fundamentally it'll work the same way. It's the same format, so we're going to get the same compression as we got in 360. But it's free for CPUs, so that's great. Oh, right. So PC, of course, has no dedicated hardware for decoding. On last game, we switched to an extremely CPU-light configuration because we wanted to get the min spec better. But fast compression means bad compression, essentially. A lot of our assets were actually shipped uncompressed, and then the other chunk of them was shipped at about 2-to-1 compression. But it was really fast. And we don't really know enough. It's likely that we'll maybe use more CPU to get the space down compromise for this, but we're a little far away to really make those judgments at this point. Okay, so the other very important aspect of any audio API on a platform is how do you actually output audio? Pretty important. Interesting notes, we're going to, across the board, go to 7.1 rendering. There's going to be essentially a mix down from 7.1 to 5.1 or 7.1 to stereo or 7.1 to mono. For those of you who sell mono televisions. The PS3, we use this library called libaudio 2, and it's a mess at best. 360 we use Xaudio 2, which is actually Microsoft's, like, supposedly it was their new replacement for Direct3D, but that didn't really work out the way they thought it would. It's also tremendous overkill because all we do is render our own audio and send out 8 channels. Orbis has this API called Audio Out, and it's beautiful. It is exactly what every basic audio output API should be. It's like 4 functions. It's like super low latency, works great. Durango uses Wasapi, which is a Windows API, except for Trevor showed you the partitions, interestingly enough. They didn't include the function to create audio devices in the dedicated partition, and so you actually have to use this COM object that like jumps over the wall to the other side. It's very strange.
Which is ironic, since actually the exclusive partition owns all of the audio device at all times.
Right, except for there's no way to get the output
Right.
without this contrived, weird method. On T6 for PC, we use X-Audio 2, much like explicitly like the 360 to make it more similar. And on that note, we'll probably move to Wasapi for T7 on PC. It actually makes more sense, I think, than X-Audio 2 at this point. At one point, it didn't. Okay, so now I will use the XFest slides here. Let's talk about the Durango hardware because it's really the the standout piece of cool audio stuff. There's this, hunk of silicon that has all sorts of audio functionality on it. There's stuff over there about Connect and other things that I'm not sure I care about either. But like this core set of these 6 green blocks are the features. We already talked about the XMA decoding. There are these buffers, and essentially what the buffer is, it takes 2 things and adds it together and tells you if a number's gone over a threshold or not, which is actually extremely useful. You do that all over the place in audio mixing. There are these 3-band parametric EQ/compression. I'll show you a slide about that in a second. It's essentially, it's not quite bass treble knobs if you're in your stereo, but it's also not that far from that. SRC is sample rate conversion. We change the pitch of sounds a lot just for variation's sake, and there's essentially a dedicated chunk of hardware to do that, which is nice because it's expensive. This is actually a really nice converter. We'll get a lot less noise out of our conversion than we have currently. There's another set of filters, these state variable filters, which is it's a different parameterization of a filter. State variable, it's actually a digital version of an active analog filter designed in the 60s. And then DMA, so you can move data over there to get processed and back. The DMA nicely includes float to short conversion, which is something you do quite often in the audio pipeline. XMA decoder, we already talked about this. There are 512 of them, which is a lot more than 360. I would have a hard time imagining we would ever use more than about 100 of them. Hello? There we go. There are these sample rate converters. These diagrams are kind of neat. Essentially, this horizontal axis is frequency. Is time, and then the vertical axis is frequency. And you can see this is what we do now is linear interpolation. And you start changing the pitch, and you get all these artifacts. They're aliasing artifacts. And then you can see this. There's less red, higher quality, better quality. Come on. This has sound examples you have to listen to. So the mix buffers are essentially just like some points in this graph. So this is just kind of a graph. You have voices, and they do sample rate conversion. You filter them, and you add them together, and you blah blah blah, and out they come. Once again, very utilitarian. It really is adding scaling and then just telling you whether you're past the threshold. I did take all the animation steps out of this. And this slide is completely messed up. So this is the state variable filter. These are just graphs to show you the different modes and the frequency response. Our day 1 use of this is going to be for the occlusion filter, which is right now it's a 1 full low pass filter, but this would be a great replacement for that, and it's free. Come on. The other EQ, these really did not format well. Is this EQ compressor step. Right now we have the EQ is a thing called a biquad, which is another, actually is a digital version of an analog filter. And we actually run quite a few, we run 4 biquads essentially right now in our mastering chain. And we have 2 compressors. So we're already doing this in our game, but this makes it free and we can use a lot more of it, which would actually be really nice. There's a lot of rerouting of signals, submixing to get, you want to compress your guns differently, compress your voices, that sort of thing, or EQ, and we'll be able to do a lot more of that. And someday, And so the DMA, that's pretty straightforward. Yeah, I mean, the exciting thing to me is the float to integer conversion, which is one other thing that just doesn't have to happen on the CPU. Okay, so the summary of that, there are 512 XMA decoders, there are 8,192 sum of the first. Oh, that number in parentheses is how many of these approximately we use for Black Ops 2. So like the number that we'll be able to use is of course dramatically higher versus what we shipped last time. So the awesome things like of our existing, say the Black Ops 2 mixer, we can move 80% of that off of CPU, which is great news, of course. Once we do that, we have, we're using 10% of what's there, 20% of what's there, and so there's a lot of features that, of course, the sound designers want to do that will be great for quality. And there's easily one whole CPU core with the power. Like it's a pretty significant amount of power. The big question, of course, is how do we make up the processing deficit on the Orbis, or do we, or is the Orbis going to be magically faster, so we have a margin there, or not? It's a big question, but we'll see about that in a year or two, I think. One other sort of depressing thing, the one thing that they could have put on here that in the hardware, which would have been better, is some help for reverb processing, because reverb is very expensive, and we still are going to have to run the CPU. In the grand scheme of things, it's not a huge percent of the total, but it would have been really nice if we could have moved some aspect of the hardware. And then Durango, this is going to entail a pretty significant either restructuring or just Durango-specific implementation of the hardware, because the current, the SD code, the sound driver code is all CPU rendering, and moving that hardware is definitely going to be big. And just last frame here is where are we? Orbis works. There are some bugs. IW6 is actually using our Orbis driver now, so I'm kind of hoping that they mature it. Should be great. Durango, the output is working. The XMA is sketchy. They haven't officially released any examples yet regarding the XMA. They gave us one early. It's been very helpful, but it's still the documentation is still very sketchy. There's still, I don't know, still some questions. And I have some other more higher priority things, so it's been sort of shelved for now. And the shape integration is going to take a while. And I've thought a lot about it, but that's about all. So there you go. More information about T7 audio than you probably wanted to know.
So Dan, what might be helpful is maybe touch on a few key points where Orbis differs from Durango on some of the key things that we've discussed, like audio hardware. What's the system reservation for CPU and memory, and how's the OS operate? Is it more traditional model like what the PS3 operates right now, or is it?
Yeah, sure. So to start with, the memory reservation is the same. I'm hopeful that Sony will back off on that, because what they did is they just talked to developers, and developers were like, oh, well, we need 5 gigabytes because that's what Durango had. So they just gave them 5 gigabytes and took 3 gigabytes for themselves. And I assume that's going to be used for live streaming of games and things like that. But I'm hoping that they'll give some of that back to us at some point. For their V-Shell or their XMD or whatever they want to call it, they have a special GPU ring. So the GPU has basically its own asynchronous processing specifically for their stuff. And the result of that is that we don't have to worry about it at all. There's no, I know on Wii there was a lot of state problems caused by their stuff, but there's nothing like that. And it's also very, very fast. So if you have an Orbis, you shift F5 to quit debugging, and it'll go back to the V-Shell pretty much instantly, which is really nice. Their CPU reservation, I believe it's, I don't think it's static. I think it's more of I wanna say it's 2 cores, but I'm not
Well,
really
they are
sure.
reserving 2 cores, but right now they're using, some of the system threads are running on our 6 cores. So if you do a capture, like CPU capture, you can see that some
Is
of
that
their.
gonna change with the next XT2?
But I think it's supposed to have, we're supposed to have those 6 cores, 100% for
Yeah,
ourselves.
we need to talk to them about it, because, yeah, I mean, we shouldn't have to deal with any of that. Otherwise, it's really similar, the GPU is better by a reasonably significant margin, and I'm expecting that we'll be able to even do some of the audio stuff on GPU, perhaps, to make up some of that if we need to. They really, really heavily designed Orbis around GPU compute, as a big focus going forward. And, early titles look like they're doing almost no GPU compute, from what people were saying at TFCon and GDC. So that'll get bigger and bigger and bigger as we go, and people have been saying that it's harder than SPU, it's actually very, very challenging, so, we'll have to get up to speed on that. CPU is the same, it's essentially an identical CPU, so. We're testing and we're seeing that Orbis is a little bit slower than Durango for CPU code, but we're not sure why. It could be that the GDR5 is better for transfers, but the DDR3 is better for like just intermediate access.
GDR normally has lower latency
Right.
than GDR.
So the GDR5 has higher bandwidth and higher latency, and I think it's the other way around, DDR3. So that's about it, I guess. Is there anything I missed?
Well, I think what we saw in performance-wise, that was really interesting, is that the CPU is about 3 times, both of them, Durango and Orbis are about 3 times faster than the 360. So the benchmark was basically to run with MP with 17 bots and compare the numbers. And it was about 3 times faster.
Yeah, and one thing that Aran also found was that it runs normal code significantly better. So we actually had, there's a define in there called vector DPPS where the portion of code was rewritten heavily to SIMD, and yet it almost ran at the same speed with that optimization disabled. So it was an optimization that was required for the older cores, but for the newer stuff, it didn't actually help as much. So we might run into more of that, where we see less and less from optimizations.
Dan, that seems like a case where the clock speed of the Xbox 360 was actually being fully realized,
Possibly,
and that
yeah.
you're just seeing that, and these CPUs are not clocked as fast.
Yeah, so that's a
there's
good
gonna
point.
be some
Like,
cases where it seems like the system is gonna be in a dead heat with the older hardware.
yeah, one thing that was mentioned in the Microsoft docs when they first came out was that the new CPUs are clocked significantly lower, so that if you had really, really good IPC from your optimized Xbox 360 code, it's likely gonna run slower on these new CPUs. But unfortunately, something like probably 1 or 2% of our code base
Yeah.
is that quality code.
We did see it with the skinning.
Skinning
Running
is like,
slower
yeah.
Yeah.
on Orbis and Durango versus the 360.
All right, guys, thank you very much. So,